Okay, continuing our discussion with fractions. Let's say we have 5 divided by 5. So we have the same number in the numerator as the denominator. What does this equal? Well, think of it this way. You have 5 divided by 5 equals what? Well, we know 5 divided by 5 equals 1. So this is 1. And in fact, any number in the numerator that matches, it doesn't matter how big or how small, the number in the denominator always equals 1. If you have the same number in the numerator and the denominator, always equals 1. Okay, another thing we can do is we can mix fractions with whole numbers. For example, page down a little bit, up too far. Suppose we have 4 3/5, or 4 plus 3/5. Let me write it like that first. 4 plus 3/5. Well, we kind of have a gentleman's agreement that whenever something like this exists, we can get rid of the plus sign and we can just write it as 4 3/5. And the way we would say this is, like I just said, we would say 4 and 3, not 5, 3/5. 4 and 3/5. Okay, so what does this represent? Well, think of this in terms of pizza. You have, say we have a pizza here that's cut into 5 slices. So here we have a 5-slice pizza. So in essence, we have 5 out of 5 slices in our pizza, or 1 whole pizza. So if we had 4 of these, what would that look like? Let's paste some more in here. 1, move this over here. 1, this up here. 3. See if the next one comes in down there. 4. So we have 4 whole pizzas. That's the 4. And then we add to this essentially we add to this a pizza that only has 3 slices left in it. So I'm going to put this over here. So just to indicate these are solid here. Pizzas. So let me go ahead. Went ahead and colored all those in. So we have 4 pizzas, 5 slices each. All 4 whole pizzas. And then this one, we only have a portion of it. 2 slices are missing. So we have this slice, and this slice. We have 3/5. So this is our 3/5. These are each 5/5, 5/5, and 5/5. Or 1 plus 1 plus 1 plus 1 is 4 plus 3/5. 4 plus 3/5, 4 3/5. Okay. Sometimes our fractions the numerator, we've seen this already, is smaller than the denominator. So in this case, we're looking at 1 divided by 10. So if we were going to do our math here, what does this equal? Well, this equals 0.1. 0.1. So this is a decimal. So decimals, that's how a decimal relates to a fraction. 0.1, this is the tenth, or 1/10. 1 over 10 is 1/10. Another way of saying that. So we can often represent our fractions as decimals. Let's try a different one. Try 3/8. So we got 3 here, divided by 8. Looks like 24, 3, but there's the decimal point is right here. So now when I subtract this, I get 6. So I have to bring down another 0 because 6 is smaller than 8. And we want to go 56 here. Subtract this. So that's 7 times 8 is 56. So now we have 4 here. That means we have to bring down another 0. So 8 times 4 is 45. And that's how we do long division. So this equals 3/8 equals 0.375. Okay, let's look at another one. How about 2/3? Well, 2 divided by 3 is, okay, again, it's smaller here. So we got a decimal up here. This is 18, which is 6. Now when we subtract this, 18 from 20, we get a 2 again. And what we end up seeing is that as we go on, this repeats. This will just keep repeating. This actually repeats forever. So you can have fractions that represents a number that repeats forever. And that's kind of a strange concept. So we have this number that we can never write down completely accurately as a decimal, because there will always be another 6 we could put down after it. But yet, we can write it 100% accurate as a fraction, a whole number over another whole number. Okay, let's say we want to convert 4 3/5 to a decimal. How might we approach that? Well, what we could do is we could, even though we're writing it this way, we understand that this means 4 plus 3/5. So this is going to be 4 plus some decimal, 3/5. So we can just then perform that math there. 3 divided by 5, 0.6. So 3/5 equals 0.6. So this is essentially the same as 4 plus 0.6 equals 4.6. So let's summarize some of these ideas. We talked about natural and whole numbers. So we could construct a number line. Say our line starts here at 0. And we can start counting 1, 2, 3, 4, 5, 6, 7, and we can continue on. That's what this arrow means. We can continue on to an infinite number of numbers, infinity here. And now we've added to that fractions. So this is 1/2. This is 3/2, or 1 1/2. But we also have decimals. Perhaps 0.6 here. Maybe 2.5 here. 3.321 maybe here. So we're constructing more numbers on our number line that we can work with, and things are becoming more and more complicated. And this is where I'm going to end this video and move on. We're going to skip section 1.4 and move on to section 1.5.